In our fourth example, we must solve the equation 2 sine squared x equals cos x plus 1 on the interval from 0 to 2 pi. You will notice that the domain this time is given in radian measure, that's in terms of pi, not in degree measure as was the case in the previous three examples. Recall that pi radians is equal to 180 degrees, and therefore to convert from degrees into radians we must multiply by pi and divide by 180. So this interval from 0 to 2 pi is actually from 0 to 360 degrees. So nothing has changed except the way in which we express our answer. It cannot be in terms of degrees, it must be in terms of pi. Now if we look at the left hand side of this equation, we have a sine squared x term, whilst on the right we have a cosine x term and a constant term. So we have two different trig functions here, a sine function and a cosine function. However, if we make use of the trig identity sine squared x plus cos squared x equals 1, and we make sine squared x the subject, then sine squared x is equal to 1 minus cos squared x. We can then substitute that into this equation as follows: 2 into 1 minus cos squared x equals cos x plus 1. Using the distributive law on the left hand side, we will get 2 minus 2 cos squared x equals cos x plus 1. Now we have an equation with only one trig function, that is cosine function. If we bring the minus 2 cos squared x onto the right hand side, thereby making it positive, and we also bring the 2 from the left hand side over to the right hand side, we will obtain a quadratic equation in terms of cosine x. So bringing the minus 2 cos squared x over, it becomes 2 cos squared x plus cos x plus 1 minus 2 when we bring our 2 across. So it looks like this, and that is going to be equal to 0. Simplifying this, 2 cos squared x plus cos x minus 1 is equal to 0. So we now have our quadratic in terms of cosine x. This will factorize in this way: 2 cos x by cos x will give us back 2 cos squared x. These two numbers must multiply to minus 1. So the only way that can happen is if one is positive 1 and the other is negative 1. Now the positive 1 will go in the second bracket and the negative 1 in the first, because when we apply the distributive law, 2 cos x by cos x, 2 cos squared x, minus cos x plus 2 cos x will give us back plus cos x, and minus 1 by plus 1 is minus 1. So at this point, either 2 cos x minus 1 equals 0, or cos x plus 1 equals 0. Cos x plus 1 is 0, or 2 cos x minus 1 is equal to 0. Now in the second case, this means that cos x is equal to minus 1, and from our knowledge of the cosine curve, we know it looks like this: y equals cos x. Cosine x is equal to minus 1 when x is equal to 180 degrees, or that is pi radians. So x equals pi radians is the solution for cosine x equals -1. So you can see why it's very important for us to know what the cosine curve looks like and also the sine curve. Moving over to the first factor, 2 cos x minus 1 equals 0 means that 2 cos x is equal to 1, and therefore cos x is equal to 1 over 2. Our reference angle alpha is equal to cos inverse of a half, which we know that's 60 degrees or pi on 3 radians. Now cos x is equal to a half, that's positive a half. Where is cosine positive? You will recall that it's positive in the first and fourth quadrants. So pi on 3 in the first and in the fourth quadrant. So we're going to pick up our solutions in the first and fourth quadrants. In the first quadrant, this is the angle that we're going to pick up. And of course, in the first quadrant, x is equal to alpha, which is pi on 3. X is equal to alpha. X equals to alpha, which is pi on 3. Now in the fourth quadrant, x is equal to 360 degrees minus alpha. So this is the angle that we're going to pick up. So you can see we would have almost made a full circle. A full circle is 360, and in this case we have to subtract pi on 3. So that angle is pi minus pi on 3. Sorry, 2 pi minus pi on 3, which is 5 pi on 3. And those are the two solutions for cos x equals to a half. So one full revolution, that's 2 pi radians. So the complete solution to this equation is, so we're going to combine all three solutions. X equals pi was the solution for cos x equals -1, and pi on 3 and 5 pi on 3 was the solution for cos x equals to a half. So we now put them in ascending order. Pi on 3, pi, and 5 pi on 3 are the three solutions to 2 sine squared x equals cos x plus 1 on the interval from 0 to 2 pi.